Hey everyone, welcome back to the channel. Today, in this live, we are going to see uh, interview questions. So let's see. I was prepared. Yeah, what is the DB context? Okay, let's start with not from here. I have created. Uh, First, we go. What is the .NET Core and .NET Framework and .NET Core? What is the .NET Core and .NET Framework? So .NET Framework is an older and Windows only platform designed to run only on Windows. So .NET Framework is an older and Windows only platform designed to run on the Windows. It does not support the cross platform development. So it does not support the cross platform development. Okay. Also, dependency injection is not built in the .NET framework. So dependency injection is not built in. So dependency injection is not built in the .NET framework. And coming to the .NET framework, it is mostly used for the building traditional desktop applications like Windows Forms and WPF and enterprise level web applications. So using the ASP.NET web forms and MVC, it is limited to the Windows only and slower the performance than .NET Core. And coming to the .NET Core, .NET Core is in a modern, lightweight, open source. It is supports the cross-platform. .NET Core is in a modern, lightweight, open source, and it is a cross-platform. So .NET Core is a modern, lightweight, and open source. It supports the cross-platform. Like it supports a cross-platform, and here in a .NET Core, built-in support for the dependency injection. .NET Core has built-in support for the dependency injection. .NET Core has built-in support for the dependency injection. In terms of performance, .NET Core is faster, especially for web APIs and microservices. It is good for the microservices and it is a cloud ready. We can move our applications to the cloud and we can host our applications in a cloud. So in a .NET framework, we cannot host our applications in a cloud. So it is only for um, on-prem databases like uh, yeah. What is the difference between? Okay, this is also same. And what is the role of, instead of this, I'm moving to the other question, very important questions. I'm here explaining the very important questions I have prepared. So let's see. Okay. Oh. Hmm. Let me open my downloads. Okay. Downloads. Okay. Here you can see. Mhm. Okay. So it's presentation mode. It is not coming. Okay. Let me explain this way only. Yeah, okay. What is the entity framework core? What is the entity framework core? Entity framework core is a modern, lightweight, open source object relational mapper. Entity Framework Core is a modern, lightweight, open source object relational mapper developed by the Microsoft. Entity Framework Core is a modern, lightweight object relational mapper developed by the Microsoft. And Entity Framework Core allows us to interact with the database using the C# classes and objects and link your queries instead of writing the raw SQL queries. EF core takes care of translating the link you queries into the SQL queries and executes it on the database and then return the results as a strongly typed C# objects. It also helps with the things like change tracking and migrations and managing the relationships between the tables, and basically it makes much easier to work with the database in a .NET. It works with the different database providers like MSSQL and MySQL and PostgreSQL and other SQLs. So the main context is what is an entity framework core means. The main context here. So entity framework core is a modern and lightweight object relational mapper developed by the Microsoft. It allows us to interact with the database using the C# classes or objects and link you queries instead of writing raw SQL queries. EF course takes care of translating the link you queries into the SQL queries and execute them on the database and then return the result as a strongly typed C# objects. It also helps with things like in a change tracking, migration, and managing the relationships and managing the managing the relationships between the table. Okay, basically it makes much easier to work with the databases in a .NET, and it also works with the different database providers. It entity framework core works with the different database providers like MS SQL Server and MySQL Server and PostgreSQL Server. Right? Okay. In a final, okay. What is the difference between entity framework core and entity framework core 6? Entity framework. So what is the difference between entity framework core and entity framework? Is the main difference is entity framework is an older version. Entity framework is an older version. Entity framework is an older version. Entity framework only works with the .NET framework. Entity framework only works with the .NET framework. Entity framework only works with the .NET framework, and it is a not cross-platform. It supports Windows only. Entity framework not a cross platform, it supports the Windows only. Entity framework has a EDMX designer support, which means we can design the entities and their relationships visually inside the Visual Studio. Entity Framework Core has EDMX designer support, which means we can design the entities and their relationships visually inside the Visual Studio. And Entity Framework generates the corresponding classes and mappings. Entity Framework uh, generates the corresponding classes and mappings. So, and supports the code first and database first approaches, but Entity Framework performance is slower because it relies on the snapshots and proxies for the change tracking and lazy loading. So Entity Framework performance is slower because it relies on the snapshots and proxies for the change tracking and lazy loading. Okay. So the main context is here. So Entity Framework Code is in a older version. It works with only data. Entity Framework Core is an older version. It only works with the .NET framework, and it does not support the cross-platform. It is supports Windows only, and it has an EDMX designer support, which means we can design the entities and the relationships visually inside the Visual Studio. And entity framework generates the corresponding classes and their mappings. And it entity framework core has a built-in support for the lazy loading. Lazy loading is built in by default in a entity framework. Lazy loading is built in by default. Okay. Coming to the entity framework core, entity framework core is complete version of EF core. Entity framework core is complete entity framework and designed for the modern applications. It is a completely rewritten version of entity framework and designed for modern applications. It works on .NET Core. It works on .NET Core and .NET 5 and .NET 6 and .NET 7. So modern .NET Core applications are used the Entity Framework Core. So older applications are used the .NET Entity Framework. So and Entity Framework Core supports the .NET 6, 7, 8, 9 like that. So it is a cross-platform. Windows and Linux and Mac OS. It works with the Windows, Linux, and Mac OS. In a entity framework core, there is no EDMX designer support. In a entity framework core, there is no EDMX designer support, which means there is no EDMX designer support, which means so technically it supports only the code first. Technically it supports only code first, but we have for example we have in a database. Still we can scaffold the entity classes and db context from the database using the command scaffold db context or .NET ef db context scaffold command. So ef core is core first only with the reverse engineering as an option. So EF core is a code first only with the reverse engineering as an option. So with the reverse engineering, we are doing this. EF core is a code first only. Yeah. EF core faster with the lightweight tracking. EF core is faster with the lightweight tracking and no proxies unless explicitly enabled. And there is no praxis unless explicitly enabled. Support advanced features like shadow properties, batching, and global query filters and own types. It supports the advanced features like shadow properties and batching and global query filters and own types. And EF core does not support the lazy loading. EF core does not support the lazy loading. EF core does not support the lazy loading. If we want to use, then we need to install the required extra packages like Microsoft Entity Framework Core Proxies. So EF core does not support the lazy loading, and if we want, then we need to require install the required extra packages like Microsoft dot entity framework core dot proxies. Yeah. So, and coming to the DB context, what is the DB context? DB context is a main class. DB context is a main class is used to interact with the databases. DB context is in a main class is used to interact with the databases. DB context class is the main class is used to interact with the database. So DB context class is the main class. It is used to interact with the database in a AF core. So DB context class is the main class used to interact with the database and handling the CRUD operations and change tracking and connection management. So entity framework core handling the CRUD operations and change tracking and connection management. So DB context is the main class is used to interact with the database in an EF core and handling the CRUD operations and change tracking and connection management. So it acts as a bridge between the database and our application code. So DB context class is it acts as a bridge between the database and our application code. It acts as a in an entity framework core. DB context is acts as a bridge between the database and our application code. It manages the entity states and it manages the entity states. So DB context is manages the entity states and tracks the changes automatically. So in a EF core, DB context tracks the changes automatically, changes of the entity automatically. So it acts as a bridge between the database and our application code. It manages the entity states and tracks the changes automatically, and it is used to query data and save the changes and configure how entities map to the database tables. So here in a DB context, it is acts as a bridge between the databases and our application code, and it manages the entity states and tracks the changes automatically, and it is used to query and save the changes and configure how entities map to the database tables. So inside the DB context, we have the two. Inside the DB context, we have the DB set properties. Inside the DB context, we have the DB set properties are defined for each table. For example, I'm defining I to work with the customer table, right? It is to work within a customer table. So also we have an on configuration as well as on model creation method. On configure on conferring on configuring and on model creating, and on configuring, on model creating and on configuring, on model creating to configure entity relationships and constraints and etc. On model creating to configure entity relationships and constraints and etc. On model creating to configure entity relationships and constraints etc. And on configuring to configure connection string. On configure is to configure the connection string. So when link queries are executed, so in a when link queries are executed, EF core uses the DB context to translate them into the SQL. So whenever link queries are executed, EF core uses the DB context to translate them into the SQL. Run them on the database and run them on the database and run them on the database and return the results and it also tracks any changes made to the entities. It also tracks the changes made to the entities, so that when the save changes is called, when the save changes method is called, it knows what to insert, update, and delete. It knows what to insert, update, or delete. So DB context is a main class is used to interact with the database and handling the CRUD operations and change tracking and connection management. And DB context is acts as a bridge between the application code and our database. In between the application code and database, it manages the entity changes, and it tracks the entity changes automatically, and it allows to query the data and save changes and configure how entities map to the database tables. And it also has the inside the DB context, we have the DB set property. DB set property is defined for each table, and we have the two methods. One is in a on configure modeling, on model configuring, oh sorry, on model on model creating and on configuring, on model creating and on configuring, on model creating to configure entity relationships and constraints, and on configuring to configure the connection strength. Okay, and when queries are executed, EF core uses the DB context to translate them into the SQL and run them on the database and return the results. It also tracks any changes made to the entities, so that save changes method is called when the save changes method is called, it knows what to insert and update and delete. So okay, relationships and constraints and mappings are usually configured in the on model creating method. So whatever relationships and constraints and mappings are usually configured in the on model creating, right? So relationships and constraints and mappings are usually configured in the on model creating method using the Fluent API. Okay, so relationships, constraints, and mappings are usually configured in the on model creating method using the Fluent API. In a web applications, DB context is typically registered in a dependency injection container, so that a new instance is created per request, ensuring proper lifecycle management. To ensure the proper lifecycle management, so to use DB context class in our application, create a class like an app DB context that derives from the DB context class. The DB context, the app DB context constructor takes the DB context options and as a DB context as an argument, and DB context options instance is then passed to the base DB context constructor, and this mechanism allows passing the configuration information to the DB context instance, such as in a connection strings and database related settings. Properties for each model class, which represents the tables in our. If I have DB set users, so if that I want to work with the users table in the database, and users defines the structure of the table, and it exposes the tables through the DB set property. So here the code you can see here, DB context in entity framework core. So public class app DB context, it is inherited from the DB context class. So you can see here DB context class. It is in a class, DB context class. Let me show in the database first. Let me show in the code. Let's see. I'm opening the Visual Studio. Okay. For the practice purpose, I have taken this one. Oh, this practice purpose I mentioned it is a TCS, so it's not. It is not from a TCS employee code. So here you can see, right. Here I have created a DB context file. So this is a DB context. So which is the main class is used to interact with the database. So right, you can see here app DB context, and it is inherited. Uh, it is DB context. Okay, see here you can see DB context is in a class. It is under the entity framework core .db context. A DB context instance represents a session with the database and can be used to query and save the instances of entities. And the DB context is a combination of unit of work and repository pattern. See here only the clearly mentioned DB context is a combination of unit of work and repository pattern. And entity framework core does not support multiple parallel operation being run on the same DB context instance. This includes the both parallel execution of async queries and any explicit concurrents used from the multiple threads. Therefore, always wait async calls immediately or use separate DB context instances for operations that execute in parallel. See, avoid DB context threading issues. For more information and examples, typically you create a class that derives from the DB context. Yes, you are creating in a typical one, app DB context and derived from the DB context class and contains the DB set properties for each entity in the model. And if the DB set properties have public setter, they are automatically initialized when the instance of derived context is created. Override the DB context uh, on configure method to configure the databases and to be used in the for the context. Alternatively, if you would rather perform configuration externally instead of inline in your context, you can use DB context options builder, or explicit externally creates an instance of DB context options and pass it to the base constructor of DB context, right. This model is discovered by running a set of conversions over the entity classes found in the dbset properties on derived context. To further configure the model, configure the model that is discovered by convention, you can override the db context dot on model creating and model builder method, on model creating and model builder method. So let's uh, go to the definitions of DB context. See, go to the definitions. If you're going into the definitions, you can see this is a DB context class. So it has an mm, see, it has a lot of methods, right? And so check for the on model creating, on model. Okay, let's check. Not any model. See here, you can see here you can see it is in a method that is protected virtual wide on configuring. So it is passing the DB context option builder. It is in a option builders. So DB context option builders. It is a class. So this is a virtual method on configuring. So you can see here on configuring override this method to configure the database to be used for this context. This method is called for each instance of context that is created. The base class implementation is nothing, does nothing. So if you implemented this, the base class implementation does nothing. In situation where an instance of DB context options may not have been passed to the constructor, so you can use DB context options builder is configured to determine if the options have already been set and skip some or all of the logic in a DB context on configuring. Okay, so we have an DB context option, right? You are passing. So coming to the here, you can see where is that controller imply, not that one. App DB context, you can see here. See here, you are passing the DB context options. App DB context as a base. Okay, on model creating. Let's see, on model creating. Override this method for further configuration. Configure the model that was discovered. So this is an override this method. You can use here you can use protected override override wide on configuring. See, on configuring, you can use the DB context option builder. So here you can mention that. So here you can define the configuration related things, like as of now we are not using this. Okay, let's go back to the not this one, this one. Yeah, okay. So this is a code. What is the difference between a DB context and DB set? What is the difference between a DB context and DB set? In a entity framework core, DB context is like a overall manager or gateway for the database. In a entity framework core, DB context is like the overall manager or gateway for the database. Right. In an entity framework core, DB context is like the overall manager or gateway for the database. It handles the task like opening and opening the database connection and tracking the changes and saving the data. So DB context class, it is used to handle tasks like opening and opening the database connection, opening the database connections and tracking the entity changes and saving the data. And on other hand, DB set is represents a specific table or collection of entities within the database. So DB set represents a specific table or collection of entities within the database, and each DB set corresponds to the table and allowing querying and CRUD operations on the particular entity. So DB context manages the database interaction as a whole, and while DB set focuses on the specific types of data within that context. Yeah. Why should DB context be scoped for request in a ASP.NET Core? Why should why should why should be scoped per request? So in a ASP.NET Core, DB context should be scoped per request to ensure one instance of the context. So one instance of the context is used throughout the entire HTTP request lifecycle. One instance of the context is used throughout the entire HTTP request lifecycle. So this approach aligns with the how EF core is designed. So EF core is not thread safe. So EF core is not a thread safe, and keeping in short lived prevents the issues like memory leaks and tracking too many entities. EF core is in a not thread safe, and keeping it short lived prevents the memory leaks or tracking too many entities. By using the scoped lifetime, the instance is shared across all the services within that request. So by using the scoped lifetime, the same instance is shared across all the services within that request, which helps which helps maintain consistency and ensures proper change tracking, ensures proper change tracking, and allows save changes to save changes to commit all updates in a single unit of work. So by using the scoped lifetime, and the same instance is shared across all the services within that request, which helps maintain consistency, ensures proper change tracking, and allows save changes to the commit all updates in a single unit of work. If we're registered as a singleton, so if you're registered as a singleton, it could lead any concurrency issues. And if we're transient, a new context would be created every time it's injected, and breaking the transaction consistency and making the changes tracking inefficient. Okay, how does EF4 track entity changes? How does entity framework core tracks the changes in entities? So entity framework core, it uses the feature called change tracking. Core uses the cha- Entity framework core uses a feature called change tracker. EF core uses a feature called change tracker to monitor and maintain the state of each entity, right? So EF core uses a feature called change tracker to monitor and maintain the state of each entity that's being tracked by the DB context. So when entities are fetched from the database using the queries like link you, and the EF core begin this transaction them automatically, and it keeps a snapshot of original values, and it keeps this transaction of it keeps a snapshot uh, of the original values. Okay, so how it tracking the how tracking works internally. When you executed query, EF core automatically starts tracking the entity, and it stores the original values and current values and state. So when you query entities from the database, when you query the entities from the database, like you are executing like in context that users dot to list. So EF code creates a proxy objects or snapshots of their original values, and keep it and keep and it keeps them, yeah, in a its change tracker. And when you are trying to modify a property when you are trying to modify a property, user.name is equal to some value you are giving. So at that time, EF core compares the current property values with the original snapshot value. Current property values with the original snapshot values. If it detects any difference, it marks the entity as modified. So it marks the entity as a modified. Similarly, if add if you're adding a new value, then it will be added as it the state will be the added. So when you call save changes, the method EF core checks the tracked entities. When you call the save changes async method, when you call the save changes async method, when you call the save changes async method, EF core checks the each tracked entities state. EF core EF core checks the each tracked entities state. EF core checks the each tracked entities state. EF core checks the each tracked entity state. Based on the state, EF core generates the SQL queries. Based on the state, EF core generates the SQL commands like and execute it against the database, then resets the entity states to unchanged. Right? So when you for example, I'm telling when you query the entities from the database, so initially if the state was unchanged, and if you're trying to modifying any property from the that context, so if you're modified any value, if EF core compares that original snapshot values and modified values. Oh, not like that way. So I'll explain you like. So when you're querying the entities to the database, right? So initially it was unchanged, and after you're querying the database, it snapshots the original values, and it creates a proxy. It creates no proxy objects or snapshots their original values and keep it them in a change tracker. Change tracker, it is in a feature in an entity framework code that stores the original values, entity states. So once it is set at it is uh, stored in a change tracker, right? So from there, when you're trying to modifying a property, uh, it compares the current property value and original snapshot value. If any detection is if it is detects any difference, it marks entity as a modified. Similar way, if you're adding in new values, then it will be the added state. And when you're after the added, then it again, when you call and save changes, it EF core checks the each tracked entity states, and based on that state, EF core generates the SQL commands like an insert, delete, update, delete. So similar way, the delete also here state. So if you're removing an object, if you're removing a property or object, so it can be removed like execute it against the database and resets the entity state as unchained. If property is modified, change tracker detects the difference between the current value and original value. When save changes is called, EF core uses EF core uses this information to generate the appropriate SQL statements and like insert, update, delete to sync those changes with the database. And EF core classifies entities into the five states like an added, modified, and detached, and uh, unchanged and detached, deleted, unchanged and deleted. So added is an entity is new and will be inserted into the database at that time. It is, so for example, you are seeing right where user is equal to new user, name is equal to Venu, and age is equal to 28, and context dot user dot add, you're adding this right here. So EF core marks the entity state as an added, and it tracks the change. It tracked in a change tracker, and when you call in a save changes like this, when you call in a save changes, EF core generates the insert statement. After saving, the state becomes unchanged since it's not existent in the database, right? Okay, EF core also updates the entity's primary key like ID if its identity generated. EF core knows it's new and marks added, executed insert, and marks the unchanged. Same thing is happened. Entity exists and has been unchanged, changed, and will be updated. Or same thing. EF core execute select query and return the entity is tracked and changes unchanged. Snapshot of original values is stored internally. Same thing. Same thing. Yeah. So entity will be removed from the database. So you can see where user context dot postal we are finding the user and removing that user, and context dot save changes, and ef4 marks the entity as a deleted, and on save changes it generates the delete sql command. So here you're removing, for adding it's a added state, and removing it is in a delete state, and after the delete state it is detached. So ef core marks the entity as a deleted, and then tracking is ef core marks an entity as a deleted, executed deleted, and the entity becomes detached after saving. Yes, okay. If you wanted to see the state of that entity, you can use this um, in a context and change tracker. It is a entities entries, change tracker entries. So from there you can easily found that entity entry dot state entity, and entity dot get type name, and so you can able to found that console log. Why db context is db context used in context entity framework core for data access. So db context in an entity framework core is used to manage data access. It represents a session with the database, keeps the tracks of entities and allows us to query and save the data. It basically acts as a bridge between the our c sharp code and database, our application code and database. What is the difference ways to configure entity properties? Okay, the different ways to configure the entity properties in a EF core. There are three main ways to configure entity properties. There are three main ways to configure entity properties. There are three main ways. So by conversion, by default rules. So for example, you have a property called property named id, so it is treated as a primary key. If it is in a properties, if string properties are there, so they're mapped to the varchar nvarchar by max, and decimal, it decimal and numeric types are inferred automatically, and the relationships are inferred from navigation properties, right? So, and data annotations are attribute based configurations. So decorate entity classes and properties with the attributes from the system model dot and data annotations, or system dot component model dot data annotation schema namespace, right? You can another way is fluent api, so code based configuration. So the fluent api provides the most powerful and flexible configuration method. It defines inside the on model creating method of your db context. So there are different ways to configure entity properties. There are different ways to configure the entity properties by default, uh, by default conversion, and there is an data annotations, and there is an fluent API, and yeah. And how do you configure relationships between the entities in a EF core? In a EF core, we configure the relationships between the entities mainly using the on model creating. So in a EF core, we configure the relationships between the entities or mainly using the on model creating. To configure, we configure the relationship between entities mainly using the fluent API on model creating. So method inside the DB context class, we use the fluent API to define relationships like one to one and one to many and many to many. For example, we can use methods like a has one, has many, and with one, and describe how entries are connected, how entities are Core also supports configuration relationships using the data annotations like foreign key, inverse property, and but Fluent API gives more flexible and control. What is the purpose of on-model creating method? This is an interesting question. On-model creating method. So the on-model creating method in a EF core is used to configure the method. The on-model creating method in a EF core is used to configure the model. So the on-model creating method in a EF core is used to configure the model and its relationships. The on-model creating method in a EF core is used to configure the model and its relationships. The on-model creating method in a EF core is used to configure the on model and its relationships using the Fluent API before the database is created or accessed. Right, on model creating method in a EF core is used to configure the model and its relationships using the Fluent API before the database is created or accessed. So it allows the developers to define how entity classes map to the database tables and configure the keys and relationships and data types and constraints and override the default conversions. And it receives a model builder object which provides APIs to consume entity model. So here you can see example protected override void on model creating model builder and model builder. You can see here model builder dot entity and type of the employee, and you're taking in a method and two table and hash key. Like this way you can mention model builder is there, right? On model creating method, model builder method class is there. So from the class we are using the entity. So purpose configure the entity to tables mapping and define the primary and foreign keys and set property constraints and data types and configure the relationships one to one and one to many and many to many. Override by default EF core conventions. So how would you handle a situation where you wanted to run SQL queries? Okay, use the methods like from raw SQL, from SQL raw, from SQL raw, or execute SQL raw, from SQL raw, and execute SQL raw for complex queries that EF4 cannot efficiently express. So use methods like from SQL raw or execute SQL raw for complex queries that EF core can't efficiently express. Use methods like from SQL raw and use from SQL raw and execute SQL raw. From SQL raw and execute SQL raw. So here just the simple thing is the SQL raw, from and execute. That's it. SQL raw and from SQL raw and execute SQL raw. That's it. These are the two methods we can use for the complex queries where we can use in a from SQL raw. We can use the from SQL raw. We use it when you wanted to run a select query that returns the entities. Select query that returns the entities. From SQL raw is used when you wanted to run select query that returns entities, and from execute SQL raw is used for commands that don't return the entities like insert, update, delete, or calling the store procedure that just changes the data. So from raw SQL is used when you want to run a select query that returns entities. And And execute SQL raw is used for commands in the entities like insert, update, and delete, or it is used for the calling the store procedures. For this, we'll see later with the example. So, how do you handle concurrency in EF core? How do you handle the concurrency in EF core? So how do you handle the concurrency in a EF core means? So in a EF core concurrency means in a EF core concurrency means handling the situation where multiple users trying to update the same data at the same time, right? In a EF core concurrency means handling the situation where multiple users are try to update the same data at the same time. See, concurrency means handling the situation where multiple users try to update the same data at the same time. In a AF core, concurrency means handling the situation where multiple users try to update the same data at the same time. So, multiple users trying to update the same data at the same time, right? So, EF core mainly supports optimistic concurrency, which means assumes the conflicts are rare. So when an entity is fetched, EF4 keeps the tracks of original values like a snapshot, and we usually add row version or timestamp column to detect if someone else changed the same record. When we call when we call save changes, when we call save changes, when we call the save change the one in the table. So if it does not match, that means it has modified the data. So EF4 throws in a DB update concurrency exception. DB update concurrency exception. Yeah, we can catch that exception and decide what to do. Either let the client win, override the database values, or let the database win, so keep the DB values, or merge the changes manually. uh, okay, client win or database win. Okay, there are also something called pessimistic concurrency, where we log the record in the database while one user is editing, but that's less common because it can cause the blocking. Okay. So, in a EF core, concurrency means handling the situation where multiple users trying to update the same data at the same time, and EF core mainly supports a optimistic concurrency, which assumes conflicts are rare. So when an entity is fetched, EF code keeps tracking of its original values and like snapshots. We usually add a row version and a timestamp. We usually add a row version of timestamp column to detect if someone else changed the same record. When we call save changes, EF core tracks the row version or concurrency token still matches the one in a database. If it does not match, that means when we call in a save changes, if the EF code checks the row version or concurrency token still matches the one in the database. So if it does not match, that means another user has modified the data. So EF core throws a DB update concurrency exception. Update concurrency exception. We can catch that exception and decide what to do. Either let the client win, override the database values, or let the database win, keep the DB values or makes the changes manually. Right? There are also something called an they are also called pessimistic uh, concurrency, where we put a lock on the record in a database, and while one user is editing, and but the less common it is a less common used. Oh, okay. And coming to the what is a eager and lazy loading in a AF core. What is a lazy loading? What is the eager loading and lazy loading in a AF core? Lazy loading loads the only when you access it. Lazy load the data, when you access it. So EF core supports lazy loading. EF core supports the lazy loading. EF core supports lazy loading, but it's not enabled by default. EF core supports the lazy loading, but it's not enabled by default. To use lazy loading, install the NuGet package Microsoft.entity framework core.proxies. Microsoft.entity framework core.proxies, and configure it with the use lazy loading proxies method in a DB context. Use lazy loading proxies method in a DB context and make the navigation properties virtual. For example, if I load a student, if EF core won't load the courses right away. So only when I access the student.courses, EF core EF core automatically sends the separate query to fetch them, and this is usually uh, but if I am not careful about it, it can cause n plus one query problem. Yeah. And you can see here AF core supports the lazy loading, but it's not enabled by default. So to use the lazy loading, install the NuGet packages like Microsoft.entity framework core.proxies, and configured with the use lazy loading proxies method in a DB context, and make the navigation properties virtual. And for example, if I load a student, for example, if I have the students and courses, if I load the students class, so it loads only the student. And if I want to the courses class, if I wanted the courses entity, so courses object, so when I access this student dot courses, AF4 automatically sends a separate query to fetch the courses. This is usually this is useful, but if I'm not careful about it, cause the n plus one problem. So eager loading load the data immediately. So eager loading load data immediately with the main query. Eager loading load the data immediately with the main query. In a EF core, eager loading uses the in EF core, eager loading uses the dot include method. In AF core, eager loading uses the dot include method to load the related entities along with the main entity in a single query. Okay. In a AF core, eager loading uses the dot include method to load related entities along with the main entity in a single query. Lazy loading delays the loading of related entities until they are first accessed. So eager loading reduce that round trips, but may bring the unnecessary data, while lazy loading saves the initial cost but cause the multiple queries, n plus one problem, if not handled carefully. So in short, AF core, EF, in short, in AF core, eager loading uses the dot include method to load the related entities along with the main entity in a single query, and eager loading in lazy loading uses the loads related data only when accessed. For that, we need to install the NuGet packages like proxies and may cause n plus one problem, and explicit loading manually load the related data with the dot load method. So it gives a full control over the entities. So coming to the, how do you handle the transactions in EF core? How do you handle the transactions in EF core means, in a EF core, transaction ensures that group of database operations are treated as a single unit of work. So in a EF core, a transaction ensures in a EF core, a transaction ensures that a group of database operations are treated as one single unit of work. Okay, a transaction that group of database operations are treated as a one single unit of work, meaning either all succeed or all fail, right? So in a EF core, transactions ensures that a group of database operations or a group of database operations are treated as one single unit of work, right? A transaction ensures that a group of database operations are treated as one single unit of work, meaning either all succeeded or all fail. So we use the transactions to make sure we use the transaction to make sure a group of operations either all succeed together or fail together. We we use transaction to make group of operation we make transactions to a group of operations either all succeeded or all failed, meaning data consistency. So how EF core handles the transactions, right? So how EF core handle the transactions? So there are three main ways you can handle the transactions in EF core. So implicit transactions using the save changes method, right? However you call in a save changes or save changes async. EF core automatically creates a transaction under the hood, and if all SQL commands succeeded, EF core commits the transaction, and if something fails, EF core rollbacks automatically. For example, context.add new product. I have added the name and price. So context.add. So this is in phone and something price. Okay, context.save changes. So this context.save changes handle automatically inside a transaction. If here something is failed in a first query, is something is failed, then it will give the error, so it cannot commit these changes. In most simple cases, you don't need to do anything manually. So here explicit transaction means when you want to when you want to the multiple save changes calls or multiple DB context, you have a multiple DB context to share the same transaction, you can manage it manually. So you can manage it manually. So here HTTP post create with an update. I'm taking post method. So create with update from body, creating the product details and okay token. Model state is valid. Return the bad request and Wait and wait at the begin transaction here. You can see await using where transaction. We are using the transaction. We are using the transaction await context.db database dot begin transaction method begin transaction async method begin transaction async method, and we use the try and catch blocks. Try catch. So in a try, what is doing, creates a new product. So, okay, we are creating a new product here and adding it to the products and save changes. And second, where existing in the product first or default async, we are finding the existing one and the existing is null, then we are awaiting the transaction dot rollback async. So if it is already there, then we rolling back the transaction, and we are seeing that return not found product with ID. And and also we are using the save changes. Okay, existing dot price, and it will commit the transaction when everything is succeeded. So return created a resource. Okay, it is return created the resource. Okay, exception throws an exception here. If it throws an exception, it will roll back the transaction. And return status code, with the return status code is then an accuracy. Okay, sharing transaction between multiple DB context. So if you're working with more than one DB context or the different databases, you can share the transactions using the underlying database DB connection. So EF core uses the transaction automatically for the save changes and use manual transaction only when you need a final control or multiple save changes. Always wrap in a try catch to handle rollback safely. Always wrap the code in a try catch black to handle rollback safety, and use logging to verify transaction behavior or when you debug. Okay, use logging to verify transaction behavior when you debug. Okay, what are the migrations? So what are the migration in an AF core or used to update the database schema. Migrations are used to update the database schema when entity classes are changed instead of manually writing the SQL queries. So EF core generates the migration files that contains in a SQL commands. EF core generates the migration files that contains the SQL commands needed to apply the changes. Running in a .NET EF migrations add, it creates a migration, and .NET EF update the database update applies it to the database. This helps to keep the code model and database structure is sync throughout the development. In a AF core, migrations are a way to keep the database schema in sync with your C# models and classes. So whenever you make changes to your entity classes or the relationships, or like adding a new property or table or relationship, and EF core helps you to apply those changes to the database with losing the existing data and creating the new one. Like, why migrations are needed? So in a real world project, you first create your model classes like employee and department. You run EF core to generate tables from those models, and later your models evolve. Okay, I need to put charging. Okay, battery is low, so we need to put the charging. So it's charging. Yeah, okay. Back to the why migrations are needed. So in a real world project, you first create your model classes like employee and department, and you run EF code to generate the tables from these models. And later your models are evolved and you add new columns and rename the properties. And manually editing the database is risky and error prone. So instead you create a migration, and EF code generates the necessary SQL commands like add migration and database EF migration in initial. So this is the code. So .NET EF database update. So it will update. So this command executes an up method from the your migration. So this execute the up method to execute and applies all the pending migration to the your database. So here we have an up and a down method. So define how to apply the changes. So and define the how to revert it. So roll back one step. So you can see here these are the commands. And okay, roll back. So these are the commands. Yeah. So this is all about the EF core entity framework core. We'll start next. We'll take 10 minutes break. After that we'll start the .NET core project. So how it is there, and yeah, we'll take now. Hmm, otherwise we'll end the stream. Okay, this is all about the EF core entity framework core. We'll start another live on the .NET core. Yeah. Thank you for watching. Yeah, bye.